Right. Welcome everyone to the second session of the day. Here we have Jamie Lennox, who has the privilege of working in entirely open source communities around OpenStack for the past few years. He still works with the OpenStack Keystone team on identity management security, but is these days mostly focused on constructing and deploying large-scale CI systems at IBM for community projects. A professional Python hacker with his head in the clouds. Please give him a warm welcome.
They never mentioned initially they were going to read that head in the clouds bit, but it's OK. All right, welcome. Thanks, everyone, for coming. Get straight in. The goal today is to explain a little bit of the approach we've built up for testing our applications that are hitting APIs. So that's a fairly generic use case. For me, it really hit home. We were developing a library called Keystone Auth. So as was mentioned, I've been working on OpenStack now for the last 4 or 5 years. Keystone Auth is a Python library that handles the trickier parts about dealing with OpenStack. So there's some, it genericizes all the authentication, does service discovery for you, does version negotiation, and some other things. And there are certain places in particular where there's a couple of multi-request sequences that have some edge cases that was sort of really difficult to get testing correct for. Obviously, we test that fairly extensively, both unit testing and against real live clouds. But today is a look at 2 of the libraries we're using for particularly the unit testing component, one of which I wrote and still maintain that I think let us do this sanely. And I've used this same approach since then on a couple of non-OpenStack projects, and it works fairly well. This is PyCon. I'm going to put code on slides, but it's fairly big, so I think we'll be OK. I labeled this hand wavy concepts, but it's more things that if you don't know what these are, you should go and research them, but can be a talk on their own. Initially, requests. So both of the libraries we're going to talk about today assume that you're using requests. At this point, requests is the de facto library for doing HTTP interactions in Python. It's not in the standard library, but even the standard library recommends you just go and use requests instead of using that. It simplifies a lot of the edge cases, so redirect handling, SSL validation, and things that just get a little bit tricky. If you're not using it, you should be, with the exception of async I/O. At the moment, I'm not aware of a good library that lets you do async I/O via requests. I don't think I should convince anybody here that you need to be testing. I'm not a particular purist about this sort of thing. I don't do test-driven development. But at this point, we're talking about how can you use your tests to do CI and continuous deployment and that sort of thing. So if it's not tested, it's broken. Unit testing and functional testing. I expect most people who have done some testing would understand this distinction. I bring it up because that's kind of the split between the 2 libraries I'm going to talk about. One of them is definitely more your traditional unit test, and one of them is a simpler integration testing. For purposes of our definition, or for today, unit testing is just you testing your own code. If you have a database or you've got real APIs that you're hitting, you can't take that hit in your unit tests. Integration testing or functional testing is then the more holistic approach of we're actually going through and executing our code in at least a semi-realistic manner, like in the way you would actually use it. And so in which case, you can set up your databases and your web servers and stuff, assuming your CI and things can handle it. Regarding mocking, there was a great talk yesterday that if you want to look into a lot more of how mocking works, at a base concept, it's the faking out of interactions that are not within your code for unit testing. So as I said, using that database example, it's isolating your code, so you're only testing your code when you do your tests. Where you should be mocking is a much harder question than what it is. As a rule of thumb, there's lots written about this, but as a rule of thumb, if you're going to do mocking, you should be mocking at the boundaries of your code. So if you have your application and it has a library and that library calls requests, and you use some of the things we're talking about today to do requests level interaction, then you can still be broken by that intermediate library changing, and for no fault of your own. So the things we're going to talk about today are typically used if you are actually calling requests yourself. Yeah, don't end up with an intermediate library in between. Okay, so I said jump straight to code, but it's pretty big. This is where people tend to start with unit testing. Mock at this point, as of Python 3.3, is in the standard library in the unit test. If you're still on Python 2, it's available off of PyPy. It's not the most intuitive library in the world, but it's the kind of the standard for mocking out anything that goes into another project. So particularly if you've already got something that you're mocking out, then you can kind of go, okay, it makes sense to continue using mock for doing your network interaction. This code mocks out the request.get function, so that function is never entered even though it's called, and that response object, this non-callable mock that we create, is returned straight away. So this works, and as I said, it's a reasonable approach, but there's a couple of downsides. The most obvious is that return value, that mock, is not a real response. All that object really has is two parameters, the JSON and the headers. If you were doing more important, and you will probably in your application be doing much more than testing those two things, it's missing the status code. It's missing functions like raise for status, which is, throw me an exception if I get a 400 or 500 error back. And it's really difficult to get that to scale beyond one call. If your unit test is doing half a dozen things, then you have to figure out, okay, in which order do I respond to them, and why do I return this response rather than a different one? So that was kind of where we got to. So you've realized that that's a fairly unsustainable approach. And so we developed a library called requestsmock. And it's a really unimaginative name for a library that works like mock does, but has an interface that looks like requests. There's a number of ways to integrate both the libraries I'm going to be talking about into your test framework, but the code, I'll keep using the context manager syntax. And this code does exactly the same as what the last snippet did. But I hope that it's a whole lot easier to understand. So things to note. When we're setting up our mocker, we're establishing it with a get, but we're specifying the URL to which this response is going to be returned. So when a request is made to the PyConAU website, it's going to return a response with a JSON body and some headers. And you can see that it's asserted down the bottom. But unlike the mock, because we're in the request library, this is a real response object like you would get back from doing a real interaction with requests. So things like status code and that raise for status that I just mentioned, they're all there and can be used without you having to go through and figure out how to put them onto your mock objects. So where that becomes really useful is you can quickly and easily set up as many of these responses as you like for different URLs or for your different unit tests. And I said, this sort of thing is super painful with mock because you then need to distinguish between when and where to return it. So exact code is not particularly important here. It does show the standard layout of how you do mocking-based tests. You tend to start off with establishing all of your mocks that you might be needing, running the code, and then at the end you call some asserts on those mockers to make sure that the right things happened in the sort of order that you expect them to. There's pros and cons to doing it this way. Pro is that I've registered 5 mocks up there and I'm only calling 3 of them. That means that particularly if you've got a lot of a class full of tests that are testing a fairly similar thing, you can establish a bunch of mocks in your setup, do the things, and make sure that only the right things were called in the test that actually matters. But the downside is you have to remember to actually call them. If something goes wrong halfway through your tests, there's not a really easy escape. This was called in the wrong sequence. Regarding how you match those requests, so once the request has been made and which response to return, there's a whole bunch of things. Method is fairly obvious in URL. I said there's an any sentinel there, so match any method. But you can do regex-based matching, scheme and query string, only return if this element is in a query string. Headers. Headers is kind of useful, particularly for doing authenticated responses. So, I've got a URL that returns a user profile, and for some complicated test you're running, which it's unit testing, don't make it too complicated, but if I hit it with this token in this header, then I return this response, otherwise return this response, and sort of distinguish it that way. And if all else fails, you can just use the callback to do your own matching. And response instruction is fairly broad as well. So it's intended to all of the parameters to look very much like what you would see in the requests library. You've got JSON, text, and content. They're mutually exclusive, so you pick the one that's returnable. Status defaults to 200. You can use as callbacks for that. So particularly if you were in a situation where the response that you return has to include elements of the request that was set, you can pipe that through via a callback. You can do cookies. Exceptions are fairly interesting. A lot of people forget to test that a 400 or 500 error is not the only way that a request can fail. If you have an SSL validation that you need to test, if you have timeouts, socket errors, that sort of thing will come through as exceptions. We can throw and test those. You can set all these up in a list. So if I hit the same URL twice, say I'm again doing an authentication request, the first time I hit a URL, I might get a 401, do some auth, hit the URL again, get back a different response the second time. So lots you can do there, and if you find something that you can't really emulate, then I'll happily add it. I feel this should be able to cover everything you can really do with the request library. And as mentioned in the others, you tend to assert then at the end of your testing that the right thing has happened. So this is probably what made the bigger difference for us rather than we could handle any response being returned. Because we were writing CLIs and libraries that were making requests, we really wanted to make sure that, okay, in my CLI, if I set this environment variable to handle certificate authority bundles, does it make it all the way through to the actual request going through? And I said, because it's sort of in the request library, what you're seeing when you do these assertions is what will actually go on the wire, not the parameters that you're passing to requests. So there's a couple of ways you can seed requests with data. There's a shortcut there that I'm using called last request, which is just the last thing to go through the mocker. But there's a history there that lets you test and test every request and response that went through the mocker in the series of your tests. And a fairly important use case, if you ever call a URL that you haven't set up a response for, that's going to fail. Prevents you having that case where your CI is making actual live requests out to the internet, which has happened. There's definitely trade-offs to using this sort of approach. As I said, I think the biggest benefit here is you can really test any scenario. Obviously, the good and bad responses, but you can do things like, what happens to your application if complete gibberish is returned? Do you handle that correctly? Regression testing. So once upon a time, you got this response from a server that is not quite what you expected. Can you handle it again in future? And as I said, the timeouts and SSL errors, you can actually put in unit testing to do all that stuff. It's easy to integrate. By default, it will, once the mocker has been started, it will intercept everything that goes through the request library. You get full access to the requests and responses. Python 2.3 compatibility is probably not as much of a selling point anymore, but particularly when we were starting to do this library, even though requests makes web interaction a whole lot easier, there are definite places where bytes versus strings matters. So if you've got a whole series of your own mocking, you probably got that wrong. We definitely did. As I said, and you're testing the protocol. So you're actually testing what requests is sending out over the wire and not what, not the parameters you passed it. There are places where you can inject data where requests will actually look at environment variables and things and insert those into your requests. And you want to actually test what the real thing that happened. There's cons. So there's definitely, you can end up in some really complex scenarios. If you're talking about you've got some really long responses, then probably somewhere you've got a file where you've dumped all of this information, and you're loading the responses in and out of all of your tests, and you've completely lost track of things. You've got callbacks that are doing, oh, maybe I'll put if statements that do. I've seen some crazy examples of people just using callbacks and constructing things on the fly. At that point, you've lost visibility into what your tests are really doing, and yeah, you're better off keeping that really simple. But that's a code management problem. Not necessarily negative, but I said in the same way as mock, you need to actually test after the fact. But the biggest problem with anything regarding mocking is that you're still mocking. So you've still got these objects that is in your code somewhere that may or may not be correct. There's no guarantee that code and responses don't change over time. You've maybe just made a complete mistake when you've copied and pasted something in. There's always the concern with mocking of anything that what you're really testing at the end is that your code works correctly in the presence of what you've mocked, which is, we hope, the same as what you'll actually see in real life. So there's a couple of strategies there that you can look up about how to keep those things correctly in sync. So to kind of, I guess, offset some of that problem there of your mocks being out of sync, we've got Betamax, and that's our choice for a fairly easy to get into integration style testing. So Betamax is a way of recording and replaying real requests that you make over the internet in your testing environments. And a quick note at the top of this, so if you're using requests, you may or may not have seen the concept of request.session. If you're using the standard request.get style APIs, there's no way there for requests to do any sort of state management across your requests. The easy things to explain there are cookies and that sort of thing. But for most people, the real win there is if you use a session, you get connection pooling. So if I make 2 requests to Google, the second time it will reuse the same socket that I made on the first request. So definitely start looking into request.session. But the author of Betamax is a guy named Ian Cadasco, who is one of the maintainers of requests itself, and a proponent of you should be using sessions. So he wrote the library in a way that forces you to be using sessions. So you start Betamax, you create a session object, you specify a cassette, and in Betamax, a cassette is where it stores its data. So in this case, everything that goes through will be stored into a file called conference schedule test. And the first time we run this, it goes actually out and fetches the conference schedule JSON from PyConAU and prints out the program. And then the second time you run it, it looks in, sees that existing cassette, and just replays that information. So the first time I ran this download, it took 9 seconds. So I'm pretty sure there's not a lot of caching going on the JSON interface for the website. Second time I ran it, it took 0.2 seconds. And you can see that it's created this 200K JSON file in my cassettes folder. And if you look at the cassette, it looks something like this. So most of the real data has been stripped out, but there's a big list there of these HTTP interactions. And they have a request and a response and some timestamps. So next time the test is run, it'll look in your cassettes directory for a cassette with that name. And if it finds one, it will load it up, and it will say, OK, the first thing I expect is a request that looks like this. So by looks like, by default, I think it matches the method, the URL, and maybe a couple of headers that it knows about. But you can do some configuration there if you're doing different things with headers. If the request does match, then it will return this response. If it doesn't match, then that's an exception. It means that what you've previously recorded with this code no longer matches what's actually happening, and you probably need to go back and re-record that request. So The expectation then is that you take all of these cassettes and you check them into your version control system and run them when you do CI. That's pushing the limits for how much code you can put on a slide. But it's fairly readable, I think. This is a more practical example a setup I've kind of found that works for me. As I said, I'm mostly interested in doing authenticated requests. There's two, so this snippet is just as, it reaches out to the GitHub API and it returns to me information about the current user based on the sort of token that's being sent. It shows off kind of two important steps. So the first one is this concept of a cassette placeholder. If you were, the first time you do this, because you are making real requests, you will probably need to inject some form of credential. And you definitely don't want that to end up in the cassette and be checked into your version control system, because that will leak the credential. So the placeholder is just basically a string replace that says if this string ever ends up in the cassette, then just replace it with this little access token placeholder. And then anytime that I'm not passing in a real request, anytime I'm not passing in a real token, I just use a random string, because so long as the placeholders are replaced in the same spot, then everything will match. The second thing is this record mode. By default, so this specifies when Betamax will re-record the cassette. By default, it's set to once, which means if the cassette doesn't exist, it'll reach out and re-record it. If a cassette exists and it doesn't match what actually happens in your requests, then it'll fail. Particularly, I said, I'm doing mostly authenticated requests, so I'd like to default that to none, because if I'm ever re-recording the cassette, then it's something I'm explicitly doing and want to do at this occasion. So yeah, and I tend to use environment variables to pass that sort of thing through. So again, trade-offs. The obvious win here is real responses. You are not copying information into your own files. It's something that you've actually reached out and fetched off the internet in a live situation. And it provides a really simple way of getting into functional testing. It's not necessarily easy, particularly depending on your setup, to create databases and create servers and all of the things that you need to do real functional testing on a regular basis. So this is a way of getting into that without having to do all that CI setup. It's a little bit more difficult to integrate. It's not hard, but it does have that session concept. So some way or another, you need to share that session between your test code and your real code. There's a whole bunch of ways you can do that. In some places, we just mock it through so that it always uses the session that we created. It can be a little bit difficult to reproduce cassettes. The idea is if you ever change that code, you should just delete the cassette and re-record it. Like, don't go in and edit those cassettes that have been recorded. But if you are doing things like creating objects on APIs, it may not be as simple as just give it an authentication, give it a token and expect that to work and re-record the same information. This is going to be application dependent, but yeah, if you are editing an existing object, maybe that object doesn't exist anymore and you can't just replay what you've got in the file. And my biggest qualm really with Betamax is that you get a bit less fidelity in what you can test. If you take the assumption that that cassette should be able to be re-recorded at any time, you can't make assumptions about what's in the cassette. So an example we have is we are reaching out to GitHub and fetching a list of the open pull requests for a project. The next time I record that, the open pull requests have completely changed. I can't make assertions based on the number of requests or who opened the different things and how that pulls through. Now, that's strictly more of a unit testing approach. However, that's the sort of thing I would like to be able to test a little bit more. Yeah, there's never a silver bullet. each approach, I said, is going to work much better in different situations, and it really is going to depend on your application and how you want to integrate this. My thoughts in general on mocking is really enjoy in moderation. The more you go overboard with mocking, the more it's going to bite you eventually. The more when you try to actually refactor that code, it's going to find something wrong. And it's super easy to end up using mocks as a crutch for basically bad application design. But yeah, I hope that between the two libraries, they've sort of cancel out enough of those problems that you can balance them out and yeah, use both. That's all. I hope everybody learned something and can use that in future. Yeah.
All right, we have about 5 minutes for questions.
Cool. I thought I was going to go way over.
Here we go.
Thanks. It's a great talk. I'm not too sure if this is. I'm just trying to figure out, get my head around the cassette. So, if there was some passwords and authentication in that cassette, would that constitute a potential security breach if you left those lying around?
Yeah. So, this is going to depend on how you use, how your version control is set up. There's some great studies about like scanning public GitHubs for looking for S3 credentials and all sorts of other things that people have checked in. Basically, it's just always a bad idea to end up with a credential stuck in your code. If your source control is an internal thing, it's never going to get leaked to the public. Well, the risks of that is not particularly great, but it's still not. Maybe not all of your team members have actual access to do that thing, even though they're working on the code. You just never want to leak a live credential. Yeah.
Cool. Thanks for that. I'm sort of wondering if there's an application to use this in Django and saying, if I go to this page and then look for a link that has this text, and I'm trying to remember the name of the project. Yesterday it was talking about doing this kind of thing. But essentially what I'm interested in is it possible to, is it an easy way in request mock to feed it either a template page or the HTML, rather than put a chunk of HTML in the code, actually refer to the thing that you would be deploying anyway, and say I'm gonna pull in that, and then I can at least check that the link says the right word or that sort of stuff. Does that even make sense?
I think I see where you're going. So that was Nick Coglin's talk, Splinter, I think it was called. So I haven't done much Django, and mostly I've been thinking of request mock for client-side stuff. So when you're actually sort of reaching out and talking to requests. Particularly with I said you can do callbacks based on data, JSON, and a few other things, but any of those, there's a few other things there where you can actually return, for example, like a full here is a response that's ready to go, and feed that into the mocker. You can return HTTP lib interfaces if you're doing that. So there's a few things there you can get quite deep that we've used in the past for doing streaming testing. I definitely think you could use request mock to build that kind of thing, but it's not something I've considered putting into the library, mostly because, as I said, that hasn't been its goal, and I've sort of gone out and scouted like how a lot of different projects are using it, and they tend to use it as a bit more of a foundational piece and then build up their assertions around it. So for example, I said at the end of when you're doing your testing, most people go through and say, okay, these requests is what were executed. Most projects I've seen that are using it then have their own assertions to say, okay, these requests with this information was called and in this order and this exact amount. And it's the sort of thing that, because everyone does it differently, I just haven't hard-coded as, this is the official way to do it. yeah, I think it's extensible enough, but it hasn't come up as a thing to put into the library itself.
So that's all the time we have for questions. Jamie, you'll find on the table there a wonderful limited edition mug for thanks on behalf of the organizers. Let's give Jamie another round of applause.